Welcome to lesson 5.2 on the Pythagorean theorem. So, the Pythagorean theorem is used for right angled triangles. And the actual formula is a squared plus b squared equals c squared, where c is always our hypotenuse. So the Pythagorean theorem can be used to find side lengths of triangles that contain a right angle, that is a 90-degree angle. So down here, I've just shown you a little bit here. In this triangle, we've got A, B, and C, and I've just labeled them as little a, little b, and little c. And here we can notice a couple of things. This little box in the corner here, this indicates that this is a 90-degree angle. So this is what we call right angled triangle. The hypotenuse is always the side that's opposite the 90-degree angle. So C here, C is our hypotenuse. So we do a squared plus b squared will equal c squared. So A and B are always the sides that contain the 90-degree angle. So we can see A and B, and the angle of 90 degrees is in between those two sides, so it contains the 90-degree angle. And sides A and B are always the two shorter sides. Side C is always the hypotenuse. It is located opposite the 90-degree angle, and it is always the longest side. So we can use this formula to find any of the three sides if we know the other two sides. So example 1, we're going to determine the length of AB, and we're going to use the Pythagorean theorem. So we can see AB is opposite our 90-degree angle here. So let's just draw that quick. We can see this is opposite our 90-degree angle. So length AB here, or line AB, that is going to be our hypotenuse. That means the other two sides are A and B. It doesn't really matter which we denote as A and which we denote as B, as long as we know that both of those sides are the shorter sides, and that C is our hypotenuse here, or line AB. So we can write this as 5 squared plus 12 squared equals c squared. So now we're just going to solve this. 5 squared is 25, plus 12 squared, which is 144, is going to equal c squared. So we're just going to add up these two numbers, and then we're going to take the square root of both sides to find c. So 25 plus 149 is 169 equals c squared. We're going to take the square root of both sides because we don't want to know c squared. We want to know c. So we're going to find the square root of 169. That's going to be equal to here. The square root and the squared sign are going to cancel each other out. So we're just going to be left with c. So square root of 169 is 13. And that's equal to c. So that means the hypotenuse is 13. We don't have units of measure here, but we can say it's 13 units long as well if we wanted to. All right, so that's our first example. Example 2 is determine the length of DF. And DF is down here, and we can see it is not opposite our 90-degree angle. Opposite our 90-degree angle is our hypotenuse, and in this case, we know our hypotenuse is 8. So we're just going to, when we use the formula, a squared plus b squared equals c squared, remember, c always refers to our hypotenuse. So when we write this, D is our hypotenuse. A squared, which we don't know, that's going to be DF, plus 5 squared equals 8 squared. Because C has to be our hypotenuse. And we know our hypotenuse here. So what we're going to do is we're going to just get A squared on all by itself on the left-hand side. We're going to bring this 5 squared over to the right-hand side. Of course, it's going to become negative when it does that. So we're going to get A squared equals 8 squared minus 5 squared. 8 squared, 64. 5 squared is 25. So now we have A squared equals 64 minus 25. We're going to just add 64 minus 25. And then we'll take the square roots of both sides and we'll find the length of A. So 64 minus 25 will give us 39. And of course, that's what A squared equals, but we want to find out what A equals. So we need to take the square root of both sides. So on the left-hand side, the square root of A squared is just going to simplify to A. And that's equal to the square root of 39. And when we do that, we'll get A equals roughly 6.24. If you left it in radical form and just said A equals the square root of 39, I would accept that as well. So the length of DF is 6.24. All right. So another one here, we're going to determine the length of GH. But this is an interesting triangle because we have a right angle. Opposite a right angle, we know our hypotenuse. Our hypotenuse is 10, but we don't know either of the other two side lengths. However, we should notice that, see these two lines here and two lines here? That indicates that the length of GI is the same as the length of GH. In other words, we have an isosceles triangle here. So GH and GI are the same lengths. So we're going to use that information to solve this. We know that HI is the hypotenuse. And we now know that HG equals GI, or GH equals GI. Therefore, A equals B, so we're just going to sub A in for B. So I'll show you what that looks like. We write our equation like normal. A squared plus B squared equals 10 squared. And now, since we know that the two side lengths are going to be the same length, instead of doing A squared plus B squared, we're actually going to sub A in for B. So it'll become A squared plus A squared equals 10 squared. We can only do this because these two sides are the same length. So A squared plus A squared is going to give us 2A squared. 10 squared is equal to 100. So before we can find out what A is, first step, we need to divide both sides by 2. So 2A squared divided by 2 is going to give us A squared. 100 divided by 2 is going to give us 50. Now, it's just the same as we've done before. We'll take the square root of both sides. Square root of A squared is just simply going to become A, and that's going to be equal to the square root of 50. And in this case, we're left with A equals 7.07. So the length of GH and GI is 7.07. I hope you enjoyed that. If you have any questions, please feel free to let me know and I will help you out. Take care.